79. All right, so page 79 when we're done. So it says so we're going to solve exponentials using logs. We're not even going to be able to get a common base for the exponentials this time. So we want to isolate the exponential expression just like we did before, and we're going to take the log of each side. That's how we have to get the variable out of the exponent. We expand them if necessary using the power rule and solve and check for extraneous solutions. Since these are exponentials, are we going to have any extraneous solutions? No, they all work. So I'm not even sure why it says that, but you don't have to do that when you're solving the actual logs. So here we have 3 to the x power equals 80. So we're going to take log of both sides. We're going to take log of 3 to the x equals log of 80. When it says expand, out of the exponent. So this exponent comes out front, and I get x times the log of 3 equals the log of 80. Now I need to get x by itself, so what do I do? Divide by the log of 3. So x equals the log of 80 divided by the log of 3. Now, even though we get to use a calculator, you have to get to this point in your work. You get equals, then you pick up the calculator. You never, ever type in decimals and write them down. Okay? So let's type it in. We do that with log of 80 divided by log of 3. So I can start with the fraction, or I can do it afterwards. It doesn't matter. I can do this. The log of is 80. Yeah, close my parentheses. Divided by the log of 3. Close my parentheses. It was 80 and 3, right? So when I get that, this is the answer I should get. And we're down to how many decimal places? 3. So I get that x equals 3.989. It said take the log of both sides. Did it say it had to be the common log? Could I have used the natural log? What do you think? Let's see what happens. So let's do the same thing. We're going to take the natural log of both sides. So the natural log of 3 to the x equals the natural log of 80. Because the natural log of 80 is different than the log of 80 as far as value is concerned, right? So when x comes out from, get x times the natural log of 3 equals the natural log of 80. The same process, x equals natural log of 3. So type that in, see what you get. The natural log button's right next to the log button, right? You get the exact same answer, or at least you should. So make sure you're pushing the buttons so you know you can get the right thing here. You get the exact same thing either way. And so which one? The natural log is one letter shorter, so we'll just use that. I asked Mr. Ackerman, and for the most part, in calculus, like moving forward after this, you're going to use the natural log is a little easier, right? We like to shorten things if we can. We'll just go with that. It really doesn't matter. If you are using E, like number 2, the natural log actually does make one step easier, but you'll get the same answer in the end. Even though the natural log of 80 is different than the log of 80, the ratio of these two things end up being exactly the same. So let's look at number 2. We're going to go ahead and use the natural log. So we'll take the natural log of both sides. Natural log of e to the x equals the natural log of 140. So x comes out of exponent, and I get x times the natural log of e equals the natural log of 140. Now, yes, I can divide by the natural log of e. What is the natural log of e? Well, e is 2.7 some. Natural log of e is 1, right? Because it's the base, so nothing cancels out. The natural log of e is 1 because if I have, here's why. I have the natural log of e equals x, right? So the base is e. So I would take e to the x power equals e, and it would be e to the first, so x equals 1. So the natural e, just like the log base 10 of 10 is 1, log base 7 of 7 is 1. So really what I end up with here is just that x equals the natural log of 140. And then you can type that in. Don't forget to work. Well, we don't have to because they're exponentials, but you're right. It does say to do that. But because my domain is real numbers, I don't need to. It's just a statement that doesn't even need to be there. So what do we get here? 4.942. Okay. Do we agree with that? Good. All right, let's jump to number 4. So all I care about is that I have a exponential equation, so it has a variable in the numerator, a variable in the exponent, and I can't get a common base on each side, so I'm going to have to use logs. So I'm going to use natural log here, and I'll take the natural log of both sides. So natural log of 1/3 to the 2x minus 5 power equals the natural log of 120. Everybody so far? The exponent comes out in front, so that 2x minus 5 comes out here. I'm going to multiply that by the natural log of 1/3. Now, when I do that, that x minus 5, I have more than one term there. It has to be in parentheses, because I want to multiply 5 times the natural log. That whole thing gets multiplied there. Does that make sense to you? That's equal to the natural log of 120. Now, I have a couple of options. I could distribute that, but I don't have to. Instead, can I go ahead and divide by the natural log of 1/3? Multiplied, I can't. 2x equals the natural log of 120 divided by the natural log of. Now, my goal is to solve for x, right? So algebraically, what do I do next? Add 5 to both sides. So I'm going to get 2x equals, that's the natural log of 120, over the natural log of 1/3 plus 5. Now I'm going to need to divide by 2. Now I could put all of this over 2, or dividing by 2 is the same as multiplying by what? 1/2. So I can just multiply both sides by 1/2, and x equals 1/2. But in parentheses, natural log of 120 over the natural log of 1/3 plus 5. And then let's go put all that in the calculator. That's going to be fun to put in. This would be a nightmare for calculators, but it's going to be kind of cool to put in. So watch this. Just hit it off. Take that 1/2. I'm going to do. Open my parentheses. I need another fraction. So I'm going to have natural log of 1 natural log. And then you have to arrow. So once you got all that, there you go. Parentheses. There's other parentheses, but this one it does because I want to make sure that you're doing. All right, good. So that we should get that x is equal to 0.321. Did everybody get that? Yes, eventually. Good, good, good. All right. So now let's look at number 5. Can I start by taking the log of both sides right now? No, I don't have that. I don't have this isolated. I have to move the 25, which means so I've got e to the 3x power equals yeah, in front of you. Think about 100. You've got 83. See how to kind of process through it that way? That's one way to think about it, but the answer is 83. Okay, so now at this point, can I take the log of both sides? Yes. So now I have the natural log of e to the 3x equals the natural log of 83. X is out in front, so 3x times the natural log of e equals the natural log of 83. What's the natural log of? So this is just 3x equals the natural log of 83. Then what do? Divide by 3. So divide both sides by 3. So x is equal to the natural log of 83 over 3. Did you get an error again? Oh, you don't have to. You can. So you don't have to put the. So you can do natural log of 83. Was it 83? And if I use my parentheses, if I hit that now, then it goes in the denominator. You just have to make sure. And then it should get right here. Okay. So that does give me 1.473. Yes. Everybody okay with that? I'm getting kind of good deal. All right. So number 6. Right now, take the log of both sides. No, I have to move what? The 2. It's -2. So I'm going to have to do, what do I do to move it? Divide. So I'm going to divide by -2. I get 8 to the 4 minus 4 equals what? 25. And it's 25. Now that I have that exponential isolated, I can take the log of both sides. So the natural log of 8 to the 4 minus x equals the natural log of 25. So when the 4 minus x comes out front, what do I have to make sure I do? Parentheses. So 4 minus x times the natural log of 8, natural log of 25. So what do I do now? Divide. Good. So I'm going to divide, and I'll get 4 minus x equals the natural log of 25 over the natural log of 8. I'm going to move that 4, so get negative x equals the natural log of 25 over the natural log of 8 minus 4. I don't want negatives. What do I want? Positive. Do that. You can divide or multiply through by -1 either way, but make sure you do that for every single term. So x equals negative natural log of 25 over the natural log of 8 plus 4. Or I guess you could put negative and put parentheses around it either way. But. All right, so get that typed in. Let's see if we can all get it typed in right. Oh yeah, the negative sign is, I had to hunt for it too. It's above. Is that what we got? I'll get the right answer. Yes. Anybody have issues? Okay, sweet. So you have -1 natural log of 25 over natural log of 8 plus 4. Oh, well, because you have, like, you can have parentheses and have a positive 4. You'd have parentheses and a -4. Does that make sense? So that's what I'm saying.
Yeah, so it would be right if I change it to.
Should be. Yep, there you go. Okay, good. Anything else? Awesome. Let's look on the book. All right, number 7. So my exponential, the first thing I'm going to have to move. The 1. So that leaves 2/3 times 2 to the x minus 4 equals 42. Then I need to move 2/3. Do that. Okay, I can multiply by 3 and divide by 2, or multiply by 3 halves. We multiply by the reciprocal. If I multiply both sides by halves, that takes care of that. These cancel out. That's the whole reason that we do it. So we get 2 to the x minus equals. So I know you have a calculator in front of you, but this is the same thing as dividing by 2, which would be 21, and multiplying by 3. 21 times 3 is 63, right? So just make sure that because you have a calculator in your hand, stop thinking about the number 100%, because then when you're not practicing it, it just makes it harder. So we get 63. Okay, so now can I take the log of both sides? Okay, so log of both sides. Natural log of 2 to the x minus 6 equals the natural log of 63. And then I get x minus 6 times the natural log of 2 equals the natural log of 63. I'll let you finish that and see if you can get the right answer in the end. So we all agree with that answer? Yes. So that gets you there. I just didn't want to make sure you could finish that up. All right, any questions at this point? So let's look at number 9. Number 9, I have an exponential on each side. And they don't have the same base. If they had the same base, that would be different, but they don't have the same base. So I'm still going to start this the same way. I still take this, and since they're both, I can take the log of both sides. So the natural log of 2 to the x plus 5 power equals the natural log of 3 to the x minus 2 power. Okay. So both of the exponents get to come out front of their respective logs, and I have to make sure I have parentheses. So I'm going to have the parentheses x plus 5 times the natural log of 2 equals parentheses x minus 2 times the natural log of 3. Now when we've gotten to this point on the other one, divided by the log, but that's not really going to help me. This would be wrong. Get me, it's going to actually make things harder. So on the other ones where I didn't distribute, because I could have, but I didn't have to, here I have to. So we have to go ahead and distribute these log. So this will give me x times the natural log of 2 plus 5 times the natural log of 2 equals x times the natural log of 3 minus 2 times the natural log of 3. Everybody understand where everything came from? Now, the whole reason we do this is so that we can do what you've been doing for every single equation you've had to solve ever, and that is trying to get all your variables on one side and all the things that aren't variables on the other side. So we're trying to solve for x. So I need all the terms that have x in them on one side of the equal sign and all the other terms on the other side of the equal sign. So this one's already over here. I'm going to leave him here because he's got x in there. So x times the natural log of 2. This is another term that has an x in it, so I'm going to subtract it over to this side. So minus x is the natural log of 3. Those are the only two terms that have x in them. On the right hand, this guy is staying over here, negative 2 natural log of 3. And then I need to move this guy over to the right. So that would be minus 5 times the natural log of 2. Okay, right with me so far? All the x terms are on the left. All the terms that aren't x terms are on the right. So I still have to be able to get x by itself. So what do you think I could do next? Like I can't actually combine them because they don't have the same log on them, right? But those two terms have something of x. So x would be considered the what? The greatest common factor. It could be the exponent, yes. I don't want to put it back up in the exponent because I just tried to get them out, right? So yes, I could make it an exponent, but that would really just, even though that wouldn't be wrong, it wouldn't be helping me any. But that x is the greatest common factor, right? Which means I can factor it out. So I'm going to factor out an x and be left with in here the natural log of 2 minus natural log of 3 equals negative 2 natural log of 3 minus 5 natural log of 2. Now, none of that's pretty, but it's not difficult. Easy. And think, oh my God, right? This is nothing compared to the things you're going to see. So write it out. Be careful with it. It's not beautiful, but it's not difficult because I'm trying to solve for x. Now what do? I can divide. I can divide by this whole term right here. So I get x equals everything that was over on the right, negative 2 natural log of 3 minus 5 natural log of 2 all over 2 minus. Thank God we not only do we have a calculator, but you have these calculators, because if you had those others, yuck. This is going to make it so nice to type in. I would suggest on here you starting with the fraction button, though, because it'll just make it easier so you don't have to worry about parentheses so much. No, you do not. You can type it in exactly like it shows on paper. The only difference is when it opens the parentheses for you, you have to make sure you close them. What's fraction? Minus 5, 2. Then numerator you can arrow down. I think I have a time. Everybody get that? Do we have any questions? So this gives you x equals 13.967. Yes. Awesome. All right. Let's do one more like this. It's a lot of writing, but really you survived. See your phone. And so same thing here. You just got to be careful with what you've got. So I've got the two terms on either side. So when you take the log, so the natural log of 8 to the 2x minus 1 equals the natural log of 5 to the x plus 3. So the exponents come out front. You get 2x minus 1 times the natural log of 8 equals x plus 3 times the natural log of 5. Everybody with me? Hector's woeing me. You with me? Delusion. Okay. Got it. Yeah, I know. You look down for too long. You're just behind. All right. So I'm going to let you kind of work through this. If you can, how far you can get without talking to you. Look on your face. What? Okay. So remember here, the next thing you have to do is you have to distribute this into there. So go ahead and do that. Okay. I'll work through it. I'm just not going to talk out loud. That if you need to look up here and follow, that's fine. But if you want to try and work through it on your own, you can too. You don't have to what? No, you don't have to put the 1. No. Well, I mean, you have to put it here. You have to put it here. Yeah, yeah, but not here. You don't have to. Okay, so let's say that at home you don't have a using your phone, and so you have to do the unreasonable another calculator. You should at least be able to get to this point, and then you can come in and use these calculators before school, after school, during math time, and just get your answers typed in. Like you can have, that last point, and then just have to type them in, and you'll be good. So make sure you type in, see if you can get number then we'll see. And if you have any questions about how I got to this point? Okay. Okay. Oh, it's not right there. I'm at this step. It's a 1. I just didn't write a 1 because it's kind of like when you have 1. It's something that you wrote. You just don't have to. So I moved this term over here, and this term got moved over here. That's why. All right. Shall I have a number you feel confident about? Be sure of yourself. There you go. Woo! All right, we all good? Wait. You're looking at this one. Thought you were looking at this point. Hang on, let me stop this.